How's it going, guys? We're looking at question number 21 on the WebAssign now. It is not uncommon during the service of a professional tennis player for the racket to exert an average force, F, of 160 newtons on the ball. If the ball has a mass of 0.065 kilograms and is in contact with the strings of the racket, as shown in figure 1118, for 0.030 seconds, what is the kinetic energy of the ball as it leaves the racket? Assume that the ball starts from rest. Assume that air resistance is negligible. So we're given a couple givens, right? We're given a couple givens. And that is the force. It's a bit too close. We're just given the force, the mass, and the time. Force is 160 newtons. The mass is 0.065 kg. The time is 0.030 seconds. Now, you might have noticed something. The three equations I have listed over there. For work, we have force, but we don't have distance, so we can't find work. For kinetic energy, you need mass and velocity. We only have mass, we don't have velocity. For potential energy, we need mass and height. We have mass, we don't have height. So how are we going to solve this question? Now, for these types of questions, you have to look at every single equation that physics has, right? So a lot of these questions, they're going to ask you to reflect. Reflect on some other things you've learned beforehand, right? Because physics builds on top of each other. Physics concepts build on top of each other. So now I've written these three equations right now, right? Now I'm going to go back and write the momentum equations. Momentum and impulse equations. Momentum is mv. And impulse is ft. And excuse me for the horrible handwriting, but look, we have force and we have time. And we have mass. So we can find velocity, because remember, momentum is equal to impulse. So mv is equal to ft. We are given ft and m. And the reason why I'm using this equation instead of one of these three is because that's the only way I can find the velocity. And once I have the velocity, I already have the mass. I can start finding the kinetic energy, then I can start finding the work, and I can start finding the height. I can do everything once I get the velocity. That's why I'm plugging it into this equation. Right? So I have the mass, which is 0.065 times v equal to 160 newtons times 0.030. I'm going to plug that into my calculator. 160 times 0. My velocity, very quick, 73.85 meters a second. Now, this ball is going very, very fast. Now we need to find what is the kinetic energy of the ball as it leaves the racket. So we need to find the kinetic energy. We're going to plug this into the kinetic energy equation. Ke is equal to 1/2 m, which is 0.065, v squared, 73.085. And we're going to do that. Oops. The kinetic energy is 173.59, oh, not 59, 0.60 joules. I'm going to double check something. Ooh, that did not work. Ah, now you see, the issue was I forgot to square this number right here. So remember always to square. I was like, wait, because I plugged my answer in to the WebAssign to double check if it was correct, right? Because I don't want to give you guys the wrong answer. So I got a final answer of 177.23 joules. I'm sorry for the long delay right there. I was just double checking and I realized, wait, I'm wrong. And if I plug that in to the WebAssign, it should say that I'm right. And indeed, it accepted the answer. So that's the correct way to do it. Remember to square it. Don't do what I did. And yeah, that's how you do question number 21 on the WebAssign.